As I mentioned when we proved that the square root of 2 is irrational, square roots really kind of came about as a way of solving problems that were related to geometry. That's where it became a relevant thing that mathematicians had to develop some ideas about. And that started from the idea of the Pythagorean theorem. And I know everybody here has learned this before, but let's just go over it really quick and we'll do a couple examples. And so for the Pythagorean theorem, it is in a right triangle with sides A, B, and hypotenuse C. A squared plus B squared always equals C squared. Okay, so there's really two main parts to this, and that is you've got a right triangle with legs AB and hypotenuse C. So the key is it's the square of the two legs is always equal to the square of the longer side, which is the hypotenuse, and this is only true if we have a right angle here. And you know, there's really two different types of examples. One example would be this, where you're given the side lengths. And so, for example, 8 and 12, and asked to find the missing side C. And so you go through and you write your equation as 8 squared plus 12 squared equals C squared. And so that gives you 64 plus 144, which is 208 equals C squared. And so then you take the square root of both sides and you get that C is equal to the square root of 208. Now, first off, note that this is a positive square root of 208 because in geometry, the lengths are always positive. C can't be negative, and so we don't have to do the plus or minus like we normally do when we ourselves insert the square root. The second thing is your book goes ahead and has you round these to the nearest hundredth. You'll definitely have some problems on your test, though, where you'll need to do simplest radical form. So I'll just do this one in simplest radical form. I know that 8 goes into 200 25 times, which means that 208 is 8 times 26. So that means 16 goes into it. And so you end up with 16 goes into 208 13 times. And so C turns out to be 4 root 13. It's always important to go through and check this and make sure it's bigger than 8 and 12 because C does need to be the longest side. The other one, and I'm going to use some lengths that are like some problems in your book, is one like this. And on this one, you might be given something like the side length is 4 and 12, and you need to find out what the missing side is. And in this case, it's the missing leg, so you just do 4 squared plus x squared equals 12 squared. So x squared equals, well, 144. Right, 12 squared is 144, subtract 4 squared, which is 16. 144 minus 16 turns out to be 128. So when you take the square root of both sides, you get x equals 8 times the square root of 2. All right, and then the second part of this is the converse. Converse means essentially the opposite order of stating something. And so the converse of the Pythagorean theorem. So the Pythagorean theorem says if you have a right triangle, then a squared plus b squared equals c squared. Well, the converse reverses that, and it says if in a triangle a squared plus b squared equals c squared, then the triangle is a right triangle. And so the Pythagorean theorem can be used as the test as well to determine, is this a right triangle? Is it not a right triangle? The key is c squared, again, needs to be the longest side. And so you might have an example like this. Determine if the following is a right triangle. This could be the sides of a right triangle. And so you might have something like, I don't know, we could say 13 and 64 and 65, and you have to determine, my bad, this should be 84 and 85. You have to determine if this is a right triangle, and so you put this into the Pythagorean theorem, and while you're putting it in the Pythagorean theorem, you're going to get 13 squared plus 84 squared equals 85 squared. Well, 13 squared is 169. 84 squared turns out to be 7,056. And 85 squared turns out to be 7,225. But if you take 7,056 plus 169, you get 7,225. And so, yes, this is a right triangle. Another one that type of problem your book asks about is something like this, where you might have is 2a, 3a, and 4a, the sides are a right triangle. Don't get freaked out about the variable. Basically, what we're saying is this is a triangle that has the sides in this ratio of 2 to 3 to 4.
So 4a is going to be the largest side, 2a is going to be the shortest side. And so when we do that,
we just have to remember how we deal with squaring expressions, and remember it's going to be like this. We put it in parentheses, so it's not 2a squared, it's 2a times 2a, which is 4a squared. And then it's not 3a squared, it's 3a times 3a, which gives you 9a squared. And so when you figure this out, does 4a squared plus 9a squared equal 16a squared? No. So that one is not a right triangle.